What's up, guys? Nitty-gritty Maths here, and today we're going to find the areas with respect to y. In the last video we did areas with respect to x. We will set the equations from last time. We will just use those. X equals 1/2 y squared minus 3 and x equals y plus 1. And when we did set them equal to one another, we did realize that the functions do intersect at -1, -2 and 5, 4. So when we do graph this out, we will get a parabola that opens leftwards, and we will get a line that intersects. And what we will find out here is that right here and right here, the area bounded here, which we are finding with respect to y, it's just from wherever these y values from -2 to 4. So right here, the area is bounded between them, right there. So that's the area. Those are going to be our C's and D's, and which I'll show you in a second what equation we do use when we integrate with respect to y, of course. So we will have A, the area, is the definite integral from C to D of the right function, abbreviated function, minus the left function with respect to y. So in this example, the right and left will be depending on how the graph looks. So we are going to graph it out here. And what we will find out, which I just drew the graph a second ago, is going to be the parabola and is going to be the line. And what we can see here, that the rightmost function will be the line and the leftmost function will be the parabola. And there's a couple ways to check, but the best way is to just graph it out. And sometimes it'll be a little tricky to see which one's left and right. Maybe they switch, they intersect, and then one becomes right and left. But you just got to use the graph, and you might need to use more than one integral with dy or dx. So here we are just going to evaluate the right minus the left function. So we already defined that the right function is the line and the left function is the parabola. So we will have the definite integral from -2 to 4. Remember where the area is trapped. I'll draw the graph one more time. Right here and right here we have points of intersection, -1, -2, and was it 5, 4. Well, this is our y value of 4, this is our upper limit, and our lower limit is -2. That's C and D for you. So, and we will have the right function, which is the line, y plus 1 minus 1/2 y squared minus 3 with respect to dy. And all you have to do now is just solve this. It's just a regular integral that we've just been doing the whole time. And we will just have this take respect to dy, and using the silent variable integration, you can do this with x's, with y's, with z's, with thetas, but we will eventually get 1/6 y cubed. I'm just going to integrate now, and I assume you can integrate, but all you have to do is the top and then the set and the bottom, and we'll get an area equal to 18. So I made what, a 14-15 minute video last time, and now we just finished this question in almost what, 5 minutes? Not bad. I mean, and I'll show you another one, and I'll just put that question up, then I'll give you a chance to do it. I'll pause the video and you can try it out. So it's going to be determine the area of the region bounded by x equals -y squared plus 10 and x equals y minus 2 squared. So find the area bounded by that region. So I'm gonna pause it. Alrighty, I hope you did pause it there and try it out. But the first thing you want to do always is set them equal to one another. So you have negative y squared plus 10 is equal to y minus 2 squared. Just do y minus 2 times y minus 2. You will get y squared minus 4y plus 4. And just add I'll just write it out for you right here. Y squared minus 4y plus 4, and what we will eventually get here is an equation that factors out to y plus 1 times y minus 3 times 2, and we'll get a y of -1 and a y of 3. So we really don't need the x's in this case since we are doing with respect to y. So our lower limit of integration will be the -1 and the upper will be 3. It's not always the case that the lower and the higher numbers are always going to be the upper and lower, so you always have to graph it out. So what we're going to do here, I'm going to leave those numbers there, but I'm going to erase one we solved for. And the graphs here look a little weird, not going to lie. It's going to be an intersection at 4 and an intersection just before 1. And the graphs look a little weird. Just like that, and just like that. So like that, and the area will be bounded between them, and our rightmost function is x minus y squared plus 10, and the leftmost function right here is going to be x equals y minus 2 squared. So what we can see here, our rightmost function is the negative y squared plus 10, our leftmost function is the y minus 2 squared. So all we have to do, plug it in the equation, and we'll call it a day. So the rightmost and the leftmost. So just keep that in mind. And I'm just going to evaluate the integral now. So the area is equal to c to d. And if you did see in the graph, I'll draw it once again. Just like that. This is your -1 and this is your 3. Some cases they can be different, but most of the time the lower will be the one on the bottom. But area you can have from -1 to 3, negative y squared plus 10 minus y minus 2 squared dy. Now you just distribute y minus 2 squared, you'll get the area. You eventually will get a polynomial of negative 2y squared plus 4y plus 6 dy, and when we integrate we will get area of negative 2 over 3 y cubed plus 2y squared plus 6y from -1 to 3. And I assume you can integrate, and we will get an area equal to 64 over 3. You can check that with the calculator, you can check it by doing by hand, but that is the end of this integrating with respect to y. Integrating with respect to x was the video before this. I just did questions, showed you how to do it with graphical analysis, and we did evaluate the integral. So that is the end of this video. I hope you enjoyed, learned some stuff that you didn't before, but nitty gritty out.